Today we'll have another lesson about aeronautical knowledge. Take this opportunity to subscribe to the channel, leave a comment, and share. Welcome aboard and have a good time. The VFR traffic pattern is a carefully choreographed sequence of flight segments repeated daily by pilots around the world. Each leg has a specific purpose, and understanding how the pattern works turns an ordinary flight into a seamless dance between skill, awareness, and decision-making. Imagine yourself flying on the left-hand circuit of a calm afternoon, engine humming steadily as you prepare to enter the first segment. The upwind leg is the initial segment flown directly above and parallel to the runway in the same direction used for takeoff. It is the extension of the takeoff roll after becoming airborne, or the segment used following a go-around to regain altitude before re-entering the pattern. With a strong headwind pushing against the aircraft's nose, the airplane gains stable lift but demands more engine power to maintain a proper climb rate. During this leg, the pilot monitors critical parameters closely: climb speed, engine temperature, pressure gauges, and the aircraft ability to maintain a steady vertical rate. It is a moment of intense focus. There's very little margin for error immediately after liftoff. Eyes alternate between the horizon, instruments, and surrounding airspace for potential conflicting traffic. So the pilot initiates a gentle left turn to enter the crosswind leg. Here, the aircraft flies perpendicular to the runway, gaining horizontal separation while continuing the climb. This segment is where the wind's lateral force becomes more apparent, often pushing the aircraft sideways. The pilot must apply drift correction to maintain a straight track over the ground. The crosswind leg is critical because the airplane is still relatively low to ground but already distancing itself from the runway environment. Vigilance is key. Radio communication, visual scanning, and maintaining a stable climb must work together. During this leg, pilots typically aim to reach traffic pattern altitude, stabilizing the aircraft before the next turn. The next major segment is the downwind leg. This is one of the longest and most important parts of the pattern. The aircraft now flies parallel to the runway once more, but in the opposite direction of landing and takeoff. From this position, the pilot sees the runway off the left wing, maintaining a consistent lateral distance, not too close, not too far, to ensure a stable base to final turn later. The downwind leg is a time of preparation. Pilots reduce power, begin configuring the aircraft for landing, check fuel selectors, adjust a mixture if needed, lower the landing gear for retractable aircraft, and set the first stage of flaps. A radio call is typically made here, announcing downwind for landing, alerting other aircraft sharing the pattern. The pilot also evaluates winds, traffic density, and runway conditions. When the aircraft reaches a point roughly abeam the runway threshold, the imaginary point where the pilot would descend if flying straight in, it is time to begin to turn onto base leg. The pilot reduces power further, begins control descent, and turns left to fly perpendicular to the runway once again. The base leg brings the aircraft from the parallel downwind path toward the alignment needed for final approach. Depending on winds, more flap may be added, and the pilot adjusts pitch and power carefully to maintain the desired descent rate and approach speed. Wind awareness becomes even more important here. A tailwind on base causes the aircraft to cover ground faster than expected, requiring quicker adjustments during the final turn. A headwind, on the other hand, stretches the time spent on base, making the descent feel slower. The pilot must anticipate these effects to avoid overshooting or undershooting the final turn. During this segment, the pilot verifies all critical landing items: proper flap setting, landing gear down, speed within limits, and confirmation that the runway is clear of traffic. It is a last chance to ensure the aircraft is fully stabilized for the approach. When the airplane reaches a proper alignment point, the pilot begins a smooth, coordinated turn toward the runway's center line, and in the final leg, also known as final approach. This is the most sensitive and demanding part of the pattern. The aircraft now aligns directly with the runway, descending steadily toward touchdown. The pilot fine-tunes power to maintain approach speed, ensuring the aircraft does not come in too fast or too slow. Every correction for wind drift is subtle but crucial. The nose must remain aligned with the runway even when the aircraft is slightly angled into a crosswind. During final approach, the pilot's focus narrows dramatically. The outside world becomes secondary. All attention is on the runway picture, descent rate, and the delicate interplay between pitch and power. If anything looks unstable, speed fluctuating, nose wandering, descent becoming erratic, the safest decision is always to go around and re-enter the pattern. Stability is the foundation of every safe landing. If everything is correct, the aircraft crosses the runway threshold smoothly. The pilot reduces power, and the airplane enters a flare, leveling out momentarily to bleed off the remaining descent rate. The main wheels touch down, and the sound of rolling tires replaces the rush of air. From here, the airplane slows down and exits the runway via the nearest taxiway. Even after touchdown, the pattern is not fully complete. The aircraft performs it after landing roll and clears the active runway, notifying other pilots via radio that it is clear of the runway. Only then is the cycle considered complete. Every leg of the VFR traffic pattern contributes to a structured and predictable flow of aircraft. It ensures that multiple airplanes can operate safely in the same airspace, offering each pilot the clarity and discipline needed to manage a safe approach and landing. The traffic pattern is more than procedure. It is a heartbeat of everyday flying, a sequence repeated countless times yet treated with precision every single flight.